All right, we're going to begin our review for our Unit 4 test. Let's get on the right. There we go. We're in the right spot. Okay, so we're going to, for these multiple choice ones, we're going to select the best answer. For the fill in the blank, we're going to write in our answer. So for the first one here, let's start off. A 4.5 kilogram ball. So I'm going to go ahead and highlight. We know by now that this is our mass. So let's just go ahead and highlight that. Is attached to a rope that forces the ball to travel along a circular path. So that's important information. Also, this vacuum is important because what a vacuum means, anytime it says vacuum in a problem, it means there's no other forces acting on the object that we're talking about. And what that's going to tell you is that the velocity is going to be a constant. It's not changing. That's the key there. All right. The rope is 2.5 meters in length, so that's important. And rotational speed of 3.5 rotations per second. So the question actually says calculate the magnitude of the tangential velocity of the ball. All right, so we have to go back and we have to remember the formula for tangential velocity. It is Vt is equal to R times the rotational speed. So in this case, if we go back up to our highlighted part, our R is equal to 2.5 meters. Our omega, or our rotational speed, is 3.5. And so we plug and play here. So our velocity then is going to be equal to 2.5 times 3.5, and that equals 8.75 meters per second. And of course that means our answer would be A, 8.75 meters per second. Okay, moving on to number 2. Number 2 says the ball breaks. So I'll just highlight that. The ball breaks. And the ball is released from the uniform circular motion. Describe what will happen to the ball. Well, if you remember back to the video we watched with the primitive weapon specialist that made the sling, he twirled it around, and then finally when he released the rock, it flew off in a straight line parallel to whatever the tangential velocity was. And essentially, that is our answer here. The ball will travel, oops, let me write it in pen instead of highlighter. The ball will travel in the direction of its tangential velocity. The ball will fly in the direction of its tangential velocity. All right, so let's move on to problem number 3. All right, a group of astronauts discovered a previously unknown solar system within the Milky Way galaxy. Over the course of their study, the scientists were able to calculate the mass of each planet and the distance from each planet to the star they orbit. So essentially what we have here, obviously, is a table of data. So we're going to be doing some comparisons. So question 3 says, Jackson claims that the gravitational attraction between the star and planet X is greater than the gravitational attraction between the star and planet Z. Is Jackson correct? Well, if we remember, force, gravitational force, is equal to capital G, which is the gravitational constant, times the mass of the first object times the mass of the second object, divided by distance squared. And so what does that mean? That means that the larger the mass, the larger the force. The greater the distance, the smaller the force. So in this case, we're comparing planet X and planet Z. So planet X, so mass 1 is equal to 3.36 times 10 to the 24th. Mass 2 equals 5.87 times 10 to the 23rd. So in this case, Jackson is correct because planet X has a larger mass than planet Z. So planet X is 3.36 times 10, sorry, put 0, 10 to the 24th. That is larger than 5.87 times 10 to the 23rd. And the key here is the exponent. So in this case, the answer would be, because it would be A. All right, a new planet, planet W, is discovered to be half the distance from the star as planet Y. The force of attraction between the star and the planet W is, well, if we think about this, we know that force and distance are an inverse square relationship. So what does that mean? That means that if distance is cut by 2, force is increased by 2 squared, or 4. So it would be quadrupled. So the answer would be D. Planet X is approximately 2.5 times 10 to the 9th meters away from planet Z. Calculate the magnitude of the force of attraction between planet X and Z. All right, planet X is approximately 2.5 meters away from planet. Calculate the magnitude of the force between planet X and planet Z. Okay, so in this one, we have to go in and do the calculations. So again, we know that force of gravity is equal to the gravitational constant times mass 1, mass 2, divided by distance squared. So what does that mean? Well, in our case, that means the force of gravity is going to be equal to 6.67 times 10 to the minus 11 times 3.36 times 10 to the 24th times 5.87 times 10 to the 23rd, all divided by 2.50 times 10 to the 9th, but that is squared. So when you put that in a calculator and you do the math, you end up with 2.106 times 10 to the 19th. And so that turns out to be answer choice C. All right, switching gears. Problem number 5. So we have a 5 kilogram rock. So we're going to make sure we note that. So a 5 kilogram rock is attached to, again, a rope that's 1.25. And we know they're alluding to radius at this point. So I'm going to put R is equal to 1.25 meters. And we also know that mass is equal to 5.0. And so the last remaining variable is our rotational speed right here, which is 3.0. So rotational speed equals 3.0 rad per second. All right, so they want to calculate the magnitude of the centripetal force acting on the rock. Well, our formula is force is equal to mass times tangential velocity squared divided by radius. Problem is, we have mass, we have radius, we have the rotational speed, but we do not have velocity. We have to go calculate velocity. And velocity is equal to radius times rotational speed. So in this case, that's going to be equal to 1.25 times 3.0. And so that'll be equal to 3.75 meters per second. Now we can take that and we can plug it back in over here. And so we get force is equal to 5 times 3.75 divided by squared, and the whole thing divided by 1.25, and that equals 56.25 newtons. Okay. All right, problem number 7 says, select the statement that best describes why the Earth continues to orbit the sun instead of crashing into the sun. Well, the Earth, when the universe was created, the Big Bang, the material that made up the Earth, flew away from that center of the explosion at a very rapid rate. And it had a very high velocity. And as we know in space, without being acted upon by an outside force, the material will continue to move at that particular speed. Well, at the same time, the sun material was shot out and it formed as well. So what happened is the Earth was flying by. The sun, because of its massive mass, actually had a large enough gravitational field to capture the Earth in uniform circular motion because of the gravity. So there's a balancing act between gravity and tangential velocity. The gravity of the sun is strong enough that the Earth cannot escape it. And so instead of escaping it, due to centripetal force, the Earth just rotates around the sun. So that's the explanation. So when we read our answer choices here, answer choice C is the correct one. All right. The sun and Mercury are attached to each other as described by Newton's law, or sorry, not attached, attracted to each other as described by Newton's law of universal gravitation. Which object experiences a smaller magnitude of gravitational force? So remember, force of gravity is equal to the constant, gravitational constant, mass 1, mass 2, divided by d squared. And what they really want you to point out in this particular question is these two terms right here are the masses. So whatever force the sun experiences from Mercury is the same force that Mercury experiences from the sun. How do I know that? Well, in one problem, if I make M1 the sun, and I make M2 Mercury, can't spell here, Mercury, and then I plug everything in, I get force is equal to M1 times M2 divided by d squared. But if I switch those two around, I would get force is equal to G M2 times M1 divided by d squared. And from our rules of mathematics, when you're multiplying, it doesn't matter the order, the answer is still going to be the same. So no matter how you order these, the answer is the same. So the answer to this particular question is they both experience the same magnitude of gravitational force. So the answer is C. All right, our last two problems. These are review type problems. So define independent and dependent variables. So an independent variable is a variable that is not dependent on any other variable. So independent. Oops. Man, that's bad. I started spelling it wrong. Independent variable is a variable that is not dependent on any other variable. It is also the variable that is purposely changed So, independent variable is a variable that is not dependent on any other variable. It is also the variable that is purposely changed to see what happens during the experiment. Now, the dependent variable, on the other hand, is the variable that the value is changed when the independent variable is changed. In other words, the dependent variable, its value is dependent on the independent variable. So the dependent variable is a variable So the dependent variable is a variable that value is changed when the independent variable is changed. In other words, we go back to when we first talked about this last semester. And if I make a change to my independent variable, my dependent variable values will change. But if I make a change to the dependent variable, it has no effect at all on the independent variable. And that's how you tell the two apart. All right, last question here. Describe what a constant is in an experiment. So a constant is the value that is held consistent throughout the experiment. It is the value that is not changed. It is uniform throughout the experiment. So a constant value that is held consistent or the same throughout the experiment. All right, well, there's all 10 review questions. Hopefully this helped. Make sure you go through it slowly. Keep asking yourself, do I understand what's going on and why? And then when you do, you should perform quite well on the exam next week. So have a great weekend. Stay safe from the snow. And I'm going to go